Yeah, I was going to turn on my camera in a second. Okay, anytime.
It's on. It's on now. Okay, awesome.
Okay, so the next speaker is Cyrus Phillips and company.
Thank you. All right, I'm Cyrus Phillips from Arlington, Virginia, just across the river over here from where we are now. And I'm the director of the Orbiter Mars Direct project, which is an all-volunteer effort to create the most realistic PC simulation of a near-future manned Mars mission. And our mission architecture is Mars Direct. So, Seth, if you could go ahead and start our little spiel here. Okay, cool. All right, and I've been advised to give a big thanks out to Rich. We are running this on Rich's laptop, and I must say it is a very cool laptop. It's about twice as fast as my desktop, so it's time to upgrade, but he's been a big help. All right, next slide, please. Okay, as I said, our goal is to create the most realistic simulation of a near-future manned Mars mission. We are committed to a quality product. We don't just want to slap something together and, have it look like crap. And we are committed to realistic simulation. We want to be as near to real world as possible. We're not looking for a space shoot 'em up where you're going to Mars and blasting aliens, stuff like that. Next slide, please. And our secondary goals, outreach is one of the big ones. Basically, we came to the realization that there's a lot of potential in this product. You tell people about Mars Direct, and you can show them a slide with a bunch of numbers and a little picture on it. Or you can run a simulation and say, okay, we're going to teach you how to fly to Mars the exact same way that NASA flies to Mars. And you're going to learn how to do it, and then you're going to learn to land the Hab on Mars just the same way that NASA hopefully will be landing the Hab on Mars for 2020. And that leads us into Orbiter as an educational tool. We have had interest from schools and teachers using Orbiter and using the Mars Direct add-on to teach students about flying to Mars. And to inspire a new generation of explorers. Young people are our greatest resource, and video games are, I loathe to call Orbiter a video game, it's a simulation, but it is a very good way to reach young people. Next slide. A little background information about the Orbiter Spaceflight Simulator. It is a closed source, freeware spaceflight simulator. It's developed by Dr. Martin Schweiger of the City College of London. The emphasis in Orbiter is firmly on realism. Orbiter is equipped with an API that allows a great deal of customization, custom spacecraft, custom panels. There are hundreds of add-ons for Orbiter, and you're going to find out a little bit more about that later. We're going to focus on Mars Direct here. Orbiter's been in development for 6 years. And the latest public version was released last May. They are doing some new stuff in the beta, which is mind-blowing. We showed it to Andy Thomas, and his jaw dropped. And I was really impressed. I was like, oh. We were like a bunch of twittering schoolgirls up there. It was pretty funny. And the site, if you want to download the core module of Orbiter, it's www.orbitersim.com. Next slide. Okay, we're going to just briefly go through our vehicles here that we're using in this add-on. Our launch vehicle is the Ares Heavy Lift Vehicle, which is proposed in Dr. Zubrin's The Case for Mars. It's a little screenshot of our of our rocket taking off. Next slide. And just another little screenshot. This is the Ares HLV taking off from Cape Canaveral. Next slide. Basically, if you're familiar with the case from Mars, you're familiar with most of these figures. Payload capabilities of the Ares HLV, SRBs. We do include some customization in our implementation of the Ares. So you can use 4 Space Shuttle main engines as the main propulsion if you like, or you can customize a little text file and switch to 4 RS-68s if you want to go that way, which would be closer to the Ares that NASA is now proposing as their heavy lift vehicle. And you can change, the upper stage is using basically a J2 class engine, which NASA also thought was a good idea. And you can change that to a Space Shuttle main engine if you so desire. Next slide, please. Okay, so when we were talking about this on our mailing list, we had a really brilliant guy, Terry Wilson of Vancouver, Canada, kind of join us and give us a lot of engineering pointers. He knows a lot more about the rocket science end of things than I do. He said, look, if we're going to be launching the Ares heavy launch vehicle manned with 4 people in the Hab, this is a shuttle-derived vehicle, and we're going to inherit shuttle-derived problems doing that. The best way to do this is to launch the Ares HLV unmanned as a cargo vehicle, then rendezvous in low Earth orbit with a capsule-type vehicle carrying our crew. And we will use a capsule-type vehicle with maximum redundancy for safety. And the funny thing about that is we had that idea a year before NASA did. So, and we did it on a budget of $0. So we kind of scooped them on that, but you know they don't give us much credit. Well, no. But if they want to use our ideas, that's fine with me. This is just a basic overview of Terry's idea for the Delta Sprint crew ferry. He proposes that we design a capsule vehicle with what is called an ogive shape, which allows for maximum internal space on the vehicle. Next slide. This is just a basic overview of some of the safety systems which are equipped on your Delta Sprint capsule. Comes in a 3-man or a 4-man version. We're using the 4-man version. Next slide. This is our mesh 3D model of the Delta Sprint vehicle. This is only a few weeks old. We did this about a month ago. We haven't integrated it into the simulator yet, but we're getting there. I think we're even working on a functional panel for it right now. And I know we're working on the interior. Next slide. Okay, moving on to the Hab module. This is our first prototype Hab module. The Hab module is modeled and coded by Mr. Ken Bali, and I believe he lives in Virginia. Basically, our idea is a folding heat shield, 4 engines, more or less the same Hab as the case for Mars. Next slide. 4-person crew, just like the book. 2 decks, same dimensions, closed-loop life support system, whole food supplies for 3 years, and I believe we've got some dehydrated food supplies for even more than that. Next slide. We did go into a little bit more technical detail on our Hab module design. We decided to put a docking port on top of our Hab module. This allows for orbital rendezvous, low Earth orbit. Also allows us to dock our Hab module to the International Space Station in our ramp up to getting to Mars in our flight program. On the bottom here, you see what we call the transit subassembly. Now, this actually separates shortly before we aero capture in the Mars orbit. It consists of the solar panels you see here, and it's kind of hard to see, but there's a heat radiator that's on the side. And when you fly this in the simulator, all of these parts are fully animated, so when you deploy the solar panels, you actually see them unfold and deploy themselves as you're in between Earth and Mars. And also, you can see our little dish antenna on top. That real-time in the simulator, it always points at Earth. So we have clear communications back home. Next slide. This is just demonstrating in orbiter the use of tether to the Ares upper stage for generating 0.38 Gs of artificial gravity. 330 meters that prevents Coriolis, keeps you from getting seasick on the way up. Next slide. This is just a screenshot of after we're coming in to land on Mars with our landing gear deployed and our 4 RL-10 engines. We use the same engines as the DCX. Next slide. And here we are at Valistau on Mars. Bruce did this screenshot for me, so I'll give him credit. It's really nice. And you can see our antenna there pointed back at Earth. There's front door right there with, I think, an American flag for a lot of the guys on the team, and the Union Jack for Dr. Schweiger, and the Canadian flag for Terry. Next slide. Okay, so moving on to the Earth return vehicle. This was our biggest hurdle in the project. We talked for a very long time about how we were going to design this vehicle. We decided to go with 4 components. The lower stage, which is used for landing and initial ascent from the Mars surface. An upper stage with 1 engine in it, and also doubles as our service module and stowage for solar panels and heat radiators. On top of the upper stage is a mission module habitat. This is used on the Mars surface as a backup for the Hab module, and once we get back to Earth, we jettison this, and this burns up in the Pacific Ocean off the coast of California somewhere. Command module is a Delta Sprint capsule with a hatch in the back that has a parasail, and we land that at Edwards Air Force Base when we come home. Next slide. Okay, so you're likely familiar somewhat with this. Propellant is Methalox. Power is, while we're in space, is 2 folding panels, solar panels stowed in stage 2. We have the SP100 reactor stowed on board for surface power. Life support systems are closed or semi-closed. Engines, lower stage, 6 35-pound thrust Methalox engines. There is already an engine on the market which uses this fuel and has that performance. It's the Glushko RD-185. We figured it would be like the RD-185, would have similar performance and similar dimensions, so we used that as our model. I don't think the RD-185 is throttleable, so it would be a derivative of that engine. Next slide. This is our basic test rendering of the ERV with our Delta Sprint command module sitting on top. We decided that since the mass budget is really tight for the ERV, the best way to do things was to leave our legs and cargo bays on the Martian surface when we launch for Earth. So this piece stays on Mars. And we take this with us. This goes all the way to Earth, and of course we jettison this before we get to Mars orbit. The next slide. This is just an exploded view of our ERV. This is actually the ERV Mark II. I'll get to that in a second, but it's mounted on the Ares launch vehicle. It's a command module, mission module. There's our upper stage, service module, and lower stage. These are just some fairings that we'll probably jettison somewhere on the trip to Mars. Next slide. This is our pressurized rover, which is stowed on the lower deck of the Hab module. It's being developed by Andy McSorley right now. Basic, pressurized rover that a lot of people have thought about. You got your remote manipulator arms for manipulating samples on the surface. Next slide. We wanted to simulate a realistic Mars direct flight program, such as NASA or whoever would actually do, similar to the Apollo program. We figure you need a minimum of 3 test flights, and we're looking at a 10-year development cycle starting in 2008. The first test flight would be flying a Hab prototype to the International Space Station, automated, not manned, and then go ahead, dock it there, use that for long-term testing and as a space hotel, which is what Dr. Zubrin proposed. The second test would be we'll shoot the Hab up into low Earth orbit, rendezvous with the Delta Sprint crew ferry, and go ahead, tether to our upper stage, spin up for artificial gravity, stay up there for 6 months, which is the same as what we do on the trip to Mars, but we'll be close to home. We'll have a Delta Sprint as an available lifeboat in case there's a disaster, we have to go home. And then we're going to do the same thing with the ERV, possibly do that in high Earth orbit. Talked to Tom Hill about that, or had some ideas from him, but it might be a good idea. We'll have to talk about that. But same thing for 6 months, which is the same as the return trip from Mars. And in our simulated flight program, we have humans on Mars in 2018. Next slide. Okay, this is an all-volunteer project, and if you've got skills in these areas, any of these areas, give me an email, and we'd love to have you. Next slide. These are just our URLs. We've got a flyer up here that's got all this information on it that you can come pick up if you want. Next slide. And this is just make sure I credit all the people that should be credited. So, okay, how are we for time? Oh, we got 15 minutes. Seth, you want to go ahead and fire the simulator up? Okay, Seth's going to go ahead and fire up some flights he's recorded. Yes.
It's right over here. So what we need to do is maybe what we'll do is just put the speaker up to the mic. Okay. That's the fastest way. We can do that. Just a little background information about Orbiter. I think he's mentioned already that it started in 2000. I joined Orbiter in 2001, right after it started. And about a year later, I joined the beta team. So I've been on the beta team developing and testing with Dr. Martin Schweiger pretty much since almost the beginning. And I've seen a lot of some of the really exciting developments come down, such as a brand new flight model, aerodynamics supporting transonic, supersonic, and hypersonic flight modes, as well as transitions between them. Fourth order Euler equations on partial or orbital perturbations, non-spherical gravity sources, and we also switched over to Bernoulli numbers on the flight model to support the hypersonics, and actually came across some really interesting artifacts in our numbers simulation time series analysis. So I know some of that might be above some of you, but it was some really interesting stuff. Just really, really cool, especially if you're looking at the calculus. And I mean, but I'll neither here nor there. We'll go right in, and I'm going to jump in and show you some of the exciting stuff about Orbiter. I did a ISS resupply launch flight last night. We'll go ahead and jump right into that. This is our splash screen, kind of showing off. This is the very latest version of Orbiter. It's still in beta, so it has not been released. And we're just loading up the textures here. I also do a project manager of Project Landsat, which is processing Landsat satellite imagery for Orbiter from the ETM instrument. And we're also working on SRTM data processing, shuttle radar topography. And I've also purchased the entire Clementine data set, which is about 300 gigs of lunar imagery, UV vis data, as well as 750 nanometer data. So I'm working on that. It takes a lot of time to process when you don't have anybody else on your team. So I'm looking for people as well. And I think my links are on the flyer as well. So this is a pre-recorded flight that I did last night with the flight stick here. Everything was stick and rudder with me. I used a couple instruments in the simulator to help me guide me to the International Space Station orbit. Obviously, this is the simulator using real physics, so the orbits are truly 3D. I can kind of spin around. The shuttle should be taking off here pretty quick. And this kind of shows off some of the really cool things about Orbiter. Hopefully it should be. Yeah, it's off pause. Is it? Oh, I don't think I did. I might not have launched the recorded value. So I'll jump back into that. I think he's right. I missed the recorded flight, so I'll have to go ahead and reload that. But we did. There was a bunch of other things that came down through Orbiter, like he was talking about earlier. Project Mercury, some of these add-ons that have come up. Project Mercury simulates the Mercury space program, and it's so realistic that the control panels, you actually have to read the manual to be able to do it properly, and learn how to fly it like a real astronaut would learn how to fly it. Now, I think this is the right one. Here we go. Thanks for helping me on that. We get rushed into these things and don't always get it right away. Yeah, that's right. The panel is historically accurate, and so much so that, like I was saying, you actually have to look at the atmospherics. There's controls there to control the suit pressure, as well as cabin pressure. You can vent the atmosphere. There's the jettison. There's control panels for jettisoning. The retro pack, the heat shield can have problems. You can have error modes, just like the real Mercury flights did. And it will also simulate Apollo 13, including all the error codes and everything that came up, and you have to respond to them and try and save power, and it can be very, very exciting. Okay, this should be just about loaded here. It's taking so long to load because I put my highest resolution textures on here, which is pretty much the highest textures you can get. Yeah, here we go. Nope, it's not paused. There we go, lift off, and clear the tower. So we got some sound effects. I don't know if you can totally hear it, but yeah, this was all stick and rudder last night. I just grabbed the stick and just fly it. Once we get into the later part of the flight, I'll go ahead and jump in and show you some of the features inside the cockpit. We have stuff for multifunctional displays that'll let you, that's actually the instruments that I use to help me guide me into orbit, to get to the right orbit, to get to the right velocity and the right time and space and window. And the guidance, it's all showing there. And of course, I'm making some corrections here, so it wasn't a perfect descent. Yeah, I can swing around here. It's totally interactive. The flight is recorded and it's just playing. So it's acting like the computer driven now. And you also notice that the laptop all of a sudden got a lot quieter. It's because the atmospherics are reasonably being simulated, and as you get up into the thinner atmosphere, there's less sound propagating away from the engines. So that's being simulated as well. And the latest version of Orbiter Sound is also supporting Mach numbers. So if you're down on the ground as a ground observer, which is a new feature, you can be watching a plane fly overhead, and then once it goes past you, you'll actually hear the sonic boom as calculated from the simulator. So it's getting to the point where there's SRB separation. Get a better view of that, possibly.
Now you can time accelerate even in the playback unless you've got it.
Yes, you can time accelerate. And now that we're approaching space here, this simulator automatically started some Mozart here to kind of go with the... It's a new feature. If any of you have ever played Winamp or played with MP3 players or anything like that, that's what Orbiter now has inside of it. It's got its own MP3 player built in. Yeah, if you wanted to throw something else in there, like I don't know, you can. There's a folder where you can dump all your MP3s, and it has full support for that. And then there's also a radio mode, so you can have a comms mode where you hear the Russians talking to you in the background from the Russian flight controllers, or you can set it up to be talking from the NASA flight controllers, so you hear English versus Russian.
You might have to time accelerate if you're going to make orbit in your time slot.
Okay. Actually, I think it's disabled because of the new beta.
Oh.
The new beta has time acceleration built into, but there's some other stuff I can.
Hit Control F5 and then you can turn that off and then you can continue to accelerate.
Well, I'm going to go ahead and go into some other stuff here.
Oh, okay.
First of all, I wanted to show this roll maneuver because I know that's
About 5 more minutes.
that's plenty. That's fine.
Yeah, actually the next talk is supposed to have been canceled, but my talk got moved up to the next slot and
Okay.
I tried to cancel it before and for some reason that didn't get processed. So you have an indefinite period of time.
Oh. Well, we've got plenty of presentations, so I mean, we can. If you guys want to see, more, I can definitely show more. I mean, there's plenty to show. I mean, there's a lot of history in spaceflight, and a lot of it has been simulated in orbiter.
Did they officially move you out, though?
Yeah, but it should have been canceled to begin with. I'm not sure why that didn't come through, but
So I would suggest just to have you go on, and then later on, if there's a slot, they can go back and.
once again, there is no talk really. We have to try to.
Yeah, and you could always come to our table as well. We've got our table out here as well. So.
This is now my talk. So. Thank you.
Well, I'm going to jump into some of the other features here of this. Just covers the external views. So one of the things that really blows everybody away is this. When I can just go like this and just keep zooming. And there's, some of the other planets. Now here's a couple other features that really kind of wow people. I'll get back in here. Is the planetarium mode. So we've got celestial objects up here. And, the ecliptic frame. We've got the ecliptic frame showing that. There's some other things in here that kind of do some nice features. The planetarium mode has some other interesting things. We got the ecliptic grid, target equator, and I can look at celestial objects, Apollo AGC navigation stars, and Messier objects. And then there's surface stuff as well. This is by planet. You can, as Cyrus said, a lot of this stuff is configurable with ASCII. So there's .cfg files that are notepad editable. You just go in there and look at the formats that are already written. A lot of the documentation is already done in PDF, so you can go and look and see at what the formats and standards are. We go down to Earth here. Let's see, there it is. And you can see Arctic stations, cities, impact features, islands, miscellaneous mountains, volcanoes, and tracking stations are all supported. And there's also some debug modes in that as well. We've got forces, body forces, total. So we can see newtons, meganewtons in the different directions, torque angles. I'm getting there. And then, of course, axes and other things for simulations. I'm going to go ahead and turn all those off because there's some other things I want to get into here. Cyrus just mentioned the virtual cockpit. This is the normal cockpit, and here's the MFDs. This is a multifunctional display on either side. Basically, I can go in here, shift F1, and we've got an orbit MFD that shows orbital parameters. We've got eccentricity, peripesis, apothesis, radius, and this is all configurable. I'm projecting on the ecliptic frame there, and I can change it to other frames as well by like that, equatorial frames. And this also displays hyperbolic orbits. This is just an orbital readout. There's other things coming up in here. We've got a map MFD that shows the surface. There's a surface MFD that shows accelerations and velocities. I mean, all the stuff is in here. All the real science is in here. Going further, the virtual cockpit, now we can see the shuttle cockpit looking out the window. talking over here. Oh, these? Oh, in the simulator? Oh, in the room. No, I don't. But then, of course, we can go to other seats like this. I can look out the other window. Lean out the window.